Okay, so talking about division with decimals, we have two more vocab words we want to add to our list. And those are terminating and repeating decimal. What does the word terminating mean? To destroy, okay. In a little less violent terms, what do we think terminating means?
To get rid of.
To get rid of, or to end, okay? So a terminating decimal is a decimal whose division ends. That means we will get to the point we have no remainder. Nothing left over at all. So, of course, the opposite of that is what we call a repeating decimal. What do you think that means? Absolutely. It's going to continue over and over, the same pattern forever. It is unending. So this will be a decimal whose digits repeat. And the way we're going to write this, if we have, for example, 4.88888, and guys, that were to continue, we would write that as 4 8/10 repeating. That little line over the top tells you that that number will repeat and never stop. You can also have a decimal that has more than one number repeating. You could have 0.56565656 that would go on forever, and we would write that as 5600ths repeating. Now our line would go over both numbers at this point because both numbers are what the pattern is repeating. You could have 3 repeating numbers. You could have a lot. But we're only going to focus on patterns that we see repeating either 1, 2, or 3 times right now. Yes?
Is pi a repeating decimal, or is it?
Pi is not.
Pi is a never-ending, uncategorized.
Absolutely. Pi is what we call an irrational number because it's not repeating or it's not terminating. It just continues and there is no pattern. Yeah.
Can we learn pi?
We won't do that this year because we won't get to circles in geometry. When you get to circles next year in 7th grade, you will use pi. Okay? Hey, remember guys, we're videoing and I want to keep it focused to what we're talking about right now. Just got through saying we won't do that until next year when you get to circles in geometry, okay? All right, so again, terminating, repeating decimals, those are the 2 vocab words you need to add to your list in your mind. Those will be on your test Friday. I will make sure I send out the link to Quizlet because those are out there you can be studying, okay? All right, so let's talk about how we divide decimals. Again, our steps over here, the first number is always inside the division bracket. So 46 3200ths divided by 0 4/10. Here is the most important rule of decimal division. Our divisor cannot have a decimal. Ever. We will not divide by a decimal. So if I can't have a decimal and I have to divide by a decimal, what do I do to get rid of it?
You need to move the decimal over.
Absolutely. I need to move it to the end to make this a whole number. So how many places do I need to move it in this number to the end? 1. So again, here's another rule. Whatever I do to the outside, I have to do the same to the inside. So if I moved it 1 time out here, what do I move it inside? 1 time. Once you've moved it, bring it straight up. And that's raising the decimal to the roof. Okay?
Raise the roof, guys.
So move it 1 time out here. If I moved it 3 times in my divisor, how many times would I move it in my dividend?
3.
3. Whatever you do out here, you do the same thing inside. At this point, we treat it like normal division, okay? Can 4 go into 4?
Yes.
How many times?
1.
1 time. Okay, we subtract, bring our next number down. Can 4 go into 6?
Yes.
1 time. This is where your handwriting becomes super important, guys, because you have to make sure that you're lining those places up. Can 4 go into 23?
Yes.
How many times? 5. Okay. Gives us 20. And lastly, can 4 go into 32?
Yes.
How many times?
8.
Okay. So you've got your decimal placed up there, but you have to make sure your numbers are in the right place, because if you don't, then your decimal's in the wrong place. So 115 and 8/10, and of course we have nothing left over. So we would call that a terminating decimal, because our division ended. Okay, let's try another. Yeah, question.
So this is basically, this is basically just regular dividing?
Absolutely. We're dividing exactly the same way. The only thing you're doing different is right here, moving your decimal and then bringing it up. Other than that, it's normal division. Okay? All right, let's look at the next one. So this time we have 496 thousandths divided by 1 2/10. So to get rid of our decimal, how many places do I move it out here? 1 place. So what do I have to do in my dividend?
Change it.
1 place. Once I've moved it, I bring it straight up. Now, can 12 go into 4? No. I'm going to put a 0 out there just because that would stand for where my whole number is. Can 12 go into 49? How many times? 4. 4 times 12, that gives me 48. Bring my next number down. Can 12 go into 16?
Yes.
How many times? Okay, that gives me 12. 4. Now, at this point, would you tell someone to bring you some cold ice? Does that make sense? Not really, because we already know ice is cold, right? Okay, so that's kind of the word, what we would call redundant. Okay, you may have heard the word but not know quite what it means. Redundant. It's like saying the same thing when it's not necessary. So if I were telling someone, wow, the snow, or that's cold snow. Well, yeah, it's cold snow because it's frozen. So when we're dealing with decimals and we have a remainder, we don't want to write our remainder as a fraction because we're talking about decimals. Fractions and decimals are the same thing. We don't want to be redundant and say the same thing 2 different ways. So we want to make sure if we've started with decimals, we're going to stick with decimals. So what do I do when I have a remainder and I'm dividing in decimals?
You add 1.
Bingo. I can tack on a 0. Does that change the value of that number? Not at all. So I can bring that 0 down. Can 12 go into 40? How many times? 3. Guys, I could keep adding on as many zeros as I want. We could keep this going. You are absolutely correct. Do you see the vicious pattern I'm stuck in?
It would just keep on going forward.
Yes. Every time I'm going to have 4 left over. I'm going to take out a group of 3. That's 36. I'm still going to have 4 left over. So what did we just find? This is a repeating decimal. So I would write my answer as 413 thousandths with the 3 repeating. And that little line just shows that the 3 is repeating. For right now, for our purposes, you will be able to recognize that it's a repeating decimal within 2 zeros. Okay? So don't freak out if you're getting the same thing after about 2 or 3 zeros, because you'll know at that point if it's repeating or if it's not. Okay?
Would it be wrong if you just noticed by only 1 0?
That's fine. As long, if you see, because I could have told you right here, that first time I got 4 as a remainder, I'd be like, well, I'm just going to get the same thing. So yeah, it's repeating. Absolutely. Okay, let's try one more. So this time we have 45 divided by 4 thousandths. How many places do I have to move my decimal here? 3. So I move my decimal 3 places in here, but where is my decimal? Where is it? Where is my decimal right now? Behind the 5. Remember, your decimal's always at the end of the whole number. So I move it 3 places. And what'd you say, Sully? I have to add placeholders. Remember, we can't have blanks. 0 serves that purpose of being a placeholder. Now we can divide. Can 4 go into 4?
Yes.
1 time. Bring our next number down. Can 4 go into 5?
Yes.
1 time. Bring our next number down. Can 4 go into 10?
Yes.
And be very careful, guys. The number that you're writing up top in your answer has to be the number above the number you just brought down. So we're bringing down another 0. Can 4 go into 20? How many times? Now at this point, whoops, I have nothing left over. But what do I have up here? I have to put a placeholder up there because there's a huge difference between 11,250 and 1,125. If I bring a digit down, which I did right here, I have to put a number above it up top. Now, if it was after my decimal point, I wouldn't have to worry about continuing to bring zeros down and all that stuff. But if it's a space in between the number you started and where your decimal point is, you have to work all the way up to your decimal point. You can't have any empty spaces once you've started there. Okay? How many of you remember this from last year? Fantastic. Again, division, guys, it's the same thing. The only thing you're doing differently is moving your decimal point and bringing it up. And then at that point, you can honestly ignore your decimal point and just divide like normal. All right? Yes, question? You have a question? You what?